Okay, so we now have a problem. So we're looking at the trigonometric ratios for this specific triangle. And what they ask us for is sine of angle A, cosine of angle A, and tangent of angle A. So I'm going to put a little dot at angle A to show where we're standing. Now, you always have to label the sides first. You think about where we're standing. I can even draw a little person here to represent point of view. There's a little person standing right there. So we have to consider what is the opposite side of angle A and our person. Well, that's going to be over here. So we have to label this opposite. Then we have to think of what's the hypotenuse. Well, we always know the hypotenuse is always across from the 90-degree angle. So we have that as hypotenuse. The other side is always adjacent, but it happens to be next to our little person, adjacent to. So I'm going to write adjacent up here. Once we label our sides, it's really easy to fill in these because this just is a clue right down here. It tells us SOHCAHTOA. So we know sine of A is going to be opposite over hypotenuse. Well, if I'm standing at A, the opposite side is 5 divided by the hypotenuse, which is 13. Then we look for cosine of A. Well, cosine is adjacent over hypotenuse. Well, adjacent I've labeled as 12, and hypotenuse is 13. Then it asks for tangent of A. Well, tangent says opposite over adjacent. Well, opposite angle A is 5, and adjacent angle A is 12. Now, it changes up as we change our perspective. So, if we move our little person and our perspective changes to asking questions about sine of C. Well, now we're looking from the perspective as if our little person is standing over here. That changes the opposite and the adjacent sides. What's opposite this guy and this point, this angle? Well, this is opposite, right? A new opposite side goes up here. Which side's adjacent? Our new adjacent side next to our little guy is right here. So it changes our ratios. So when we ask for sine of C, the hypotenuse stays the same. Sine of C is opposite over hypotenuse. Well, now it's going to be opposite side of our perspective over here. It's going to be 12. Sine's over opposite over hypotenuse. Hypotenuse is 13. Then we can look at cosine is adjacent over hypotenuse. Well, we're still cosine of angle C. It's adjacent over hypotenuse. So we've got 5 over 13. And then tangent of angle C would be opposite over adjacent. So it's going to be opposite side, which is 12 over adjacent, which is 5. And you might say, why do we hear about this? You just wrote a bunch of fractions. And these fractions show you, they represent the ratios of the sides to other sides and can help you find the missing angles. So if we have these sides, we can find what this angle is. We don't know now, what could this angle be? But if we know it's a right triangle and we know the opposite length of the opposite side, the hypotenuse, and the adjacent side, we can now figure out missing angles. And I'll show you how to do that on the next lesson. For now, we're going to go try to figure out what the ratios are for opposite sides, adjacent sides, hypotenuse sides, just like it's written out here. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse.